Concrete is one of the most versatile and widely used materials in construction. It's the foundation of our buildings, bridges, roads, sidewalks, dams, and much more. Everywhere you look, concrete is part of the landscape. But have you ever wondered how concrete is made? Concrete is a mixture of aggregates, admixtures, water, and cement. Aggregates are granular materials that add volume to the mixture, such as gravel or crushed up concrete. Admixtures are materials that change the mixture's properties, like its hydration. And cement is the glue that holds it all together. Think of it like baking a cake from scratch. Each ingredient plays an important role. The ratios of these ingredients determine things like the density, moisture content, and setting time of the final product. Once mixed, the concrete is poured into molds, taking on the shape of whatever it's intended to be. It then needs time to set. Through a chemical reaction called hydration, the concrete hardens, gaining strength and durability over time.
However, concrete isn't without its drawbacks. Concrete production has a significant environmental impact, contributing to about 8% of global CO2 emissions each year. Additionally, the increased heat absorbed by concrete compared to natural ground such as dirt, grass, or snow causes the surrounding area to heat up more than it otherwise would in a process known as the urban heat island effect. Concrete ground cover also has implications for water runoff, as less water can work its way down into the soil, causing flooding to be more likely during intense rainfall. Cement is the main ingredient in concrete, acting as a binding agent for the mixture. During cement production, limestone is heated to very high temperatures to produce lime, which can then be used to make the cement. Critically, the chemical reaction that results from heating this limestone directly releases carbon dioxide emissions, meaning that these emissions are unavoidable during cement production. Powering the cement kiln also requires a substantial amount of energy, and this energy can produce a lot of greenhouse gas emissions if it is sourced from fossil fuels. So what can be done about this? To reduce emissions coming from the cement kiln's energy requirements, clean power can be utilized, such as green hydrogen for combustion. Green hydrogen is simply hydrogen produced from splitting water, or H2O, using renewable energy, producing no greenhouse gases in the process. Around the world, researchers and companies are also exploring ways to capture and store carbon dioxide in an effort to reduce our environmental footprint. One promising solution involves capturing CO2 from the air and permanently storing it in building materials like concrete.
One popular method for capturing CO2 from the air and permanently storing it in concrete is carbon mineralization, which is a natural process that can be accelerated using innovation and technology. In this process, carbon dioxide reacts with alkaline minerals typically found in rocks. Over time, this reaction forms carbonates, which are aggregates with a high concentration of carbon dioxide. Some startup companies are bringing technologies to market that capture carbon dioxide in concrete. Synthetic limestone aggregates, which are 44% carbon dioxide, can replace mined limestone aggregates. And carbon dioxide-infused supplementary cementitious materials, which are based in recycled industrial waste products from the coal and steel industries, can replace the cement. And precast concrete can also be infused with carbon dioxide either in the curing or mixing phases. Taking CO2 from our atmosphere reduces global warming, offsets the high carbon emissions of concrete production, and creates valuable products. Concrete with carbon dioxide embedded has increases in strength, less can be used for the same application, leading to money savings.
Alternative concrete startups are currently only economically viable thanks to carbon dioxide removal credits. These credits are bought by other companies that want to reduce their carbon dioxide emissions but are having trouble reducing emissions by changing their own products and processes. Instead, by buying carbon dioxide removal credits from companies like those that produce carbon dioxide storing concrete, they can count the emissions reductions from these carbon negative products in their own environmental reporting. To change this, we need further research on scaling up green technologies, strategies to improve their economic viability, government policies to encourage adoption of new technology, and greater awareness. In summary, reducing the high CO2 emissions of concrete could make a large contribution to climate change mitigation efforts. Embedding captured CO2 within the concrete mixture is one strategy to green the concrete jungle.